All right. I would suspect that you guys have heard this idea that the shortest distance between 2 points is a straight line. Well, we're going to use that idea here, finding the distance from a point to a line. Now, again, the shortest distance is always going to be a straight line, but it's going to be a certain kind of straight line. When I am looking at this, what's closer to point P, A or B? B. It's kind of obvious, isn't it? Now, when we're doing this, it actually turns out that the perpendicular line is going to be the shortest. So what we're going to do here is we're going to be going and taking a look at how we can identify what the distance is based on this idea that they're going to be perpendicular. So let's look at this. Which point is closer, N or L? Probably N. Why do you say probably N? It looks closer. Okay, that's what we're really looking at. There's the distance here. If I take a look at how far it is from here to here, it looks like it's 1, correct? And if I go over here, it looks like it's probably 1. Okay, we'll just go 1.5. It's further away, right? Now, if I were to use that Pythagorean theorem idea, this distance here is going to be 4, correct? So if I've got a right triangle here where I end up having 1.5 squared plus 4 squared is equal to our c squared, or if I do it over here, 1 squared plus 4 squared is equal to c squared, which one's going to be a smaller value, the left side or the right side? The right side, because you only got 1 squared plus 4 squared versus 1.5 squared plus 4 squared. So N has to be closer, but we want to look at it for the distance on the side, not the angle. Okay. So I'm going to give you a few moments here, and I want you to write down these into your little book. All right. So through a line and a point, not on the line, there's exactly one perpendicular line. Well, we've seen this before where we've got, for any 2 given points, there is only 1 line. Okay, and again, the perpendicular segment from a point to a line is going to be the shortest segment from the point to the line. So let's try this. Say, for example, that I want to find the distance from 0.64. 1, 2, 3, 4, 5, 6. So there's my point. Now the first line that I want to do here is y is equal to 1. Now just remember, this is the y-axis up here, this is the x-axis here, and if I want y is equal to 1, that means y1 is right here. So I've got my line going to go through right here. So now if it's supposed to be perpendicular as the shortest, that means I can just come straight down, isn't it? Because this is a horizontal line, a vertical line would be perpendicular. So I just have to count down 1, 2, 3. So this would be 3 units. That makes sense? So what about the next one? I want to find the distance to x equal 1. Well, x equal 1 is going to be right here. It's a vertical line. So I need to have my vertical line right there. How far is it going to be away for this one? If we count over, so this is going to be 1, 2, 3, 4, 5. So we got 5 units here, 5 units. Now, what about to the other line that they got here? Y is equal to x. What kind of a line is that? Okay, it's going to go through the origin. We know that. So we got 1 point there. So what would be another point? I want another point. Let's see, if we got to come up with that, let's do this. X, Y, we got 0 and 0. What would be another point that I could choose? 1, and what would I get? 1. So that means that I got a point here. And let's see, what would be another point that I could choose? 2 and 2. We got that there. So it looks as though I will have a diagonal line here. Okay. So what I need to be concerned about here is how far is that away, correct? Well, can I just count it as 1? No, that won't quite work. Let's see if I can't get in a little closer. So, can't do it that way. Let's try this here for a second. I'll erase a few things. Let's get rid of that. Let's put our point back. Let's see. So there's my point there. So, distance. We know that the distance is going to have to be going straight there, and it's going to be perpendicular. Problem is, how do I determine that distance? Well, I'm on a coordinate grid. If I go and draw a triangle in like this, do I have a right angle down here? Does that mean I can use the Pythagorean theorem with a distance of 1 here and a distance of 1 there? So that means I would have 1 squared plus 1 squared is equal to c squared. Well, that's just 1 plus 1 is equal to c squared. 2 is equal to c squared. So the square root of 2 is equal to c. And unfortunately, that's all the further we can go with it. We can only go through and say that the distance here is going to be a grand total of square root 2 units. That's all that we can do. So having it on a coordinate plane, being able to count it out is kind of nice. Because it's not 1. So what you're telling me is that, okay, let's go down here. I need a little bit more space. Okay. I want to make a triangle. That's this. I'm going to call that, that's a little long for what I need right now, but that's 1 unit, okay? 1. So, copy and paste. Let's see, copy, paste. Let's see, then I want format. I want to flip. I ain't going to do any good. I don't have nuts. That's why I don't use lines. Shame upon me. Let's try that again. Nope, wrong one. Okay, getting back to this again. I'm going to call this 1 unit. Copy, paste. Now I get to rotate 90 degrees. So if I go and put this in and say that, okay, I go 1 unit this way, and then I go up 1 unit, okay? Are you trying to tell me that the distance from here over to here is also going to be 1? Is that what you're implying? Okay. So if I go and hit paste, I've still got my same line in here, right? So I bring that down here, and if I try and put this here at a 45-degree angle or whatever angle it takes to go in there, that's all the further I can get. So I can't make it, can I? See, this is where the Pythagorean theorem comes into play. A squared plus B squared is equal to C squared. We talked about that quite a bit. Think about it on a set of steps. If you're going up the same distance and in the same distance, this diagonal distance here is going to be by far longer. Same thing with putting a ladder up. You lean something against the wall. Same idea. This distance is always going to be how far left, right it is squared, how far up and down it is squared. Add it together and square root it. That's the way it is. That's the geometric explanation for it. This is only as obvious as I can make it for you. I mean, you could do it with yardsticks. I could take the yardsticks over there since they're all the same length. This distance here cannot be the same as this way. Does that make sense to you? Think of it as a visual thing, not so much as by the numbers. So let's try this. Finding the closest point on a line to a point. Now, the shortest distance is always going to be this idea of a perpendicular line. So if I've got this line up here, what's the slope of this line? Well, the slope of this line should be whatever is right here. So that means this slope is going to be 2. Okay? What is the slope of the perpendicular line? Remember what that was? Nobody remembers what the perpendicular slope is going to be? Yep, it's going to be the reciprocal, and it's also going to be the opposite. So negative 1/2. This is going to be the slope of the perpendicular line. So I got to go through this point. If I'm doing a slope of down 1 over 2, down 1 over 2, down 1 over 2, puts it this way, but I can also go back 2, up 1, back 2, up 1, back 2, up 1. I found the point. So the point turns out to be here at 1, 3. Now, what's the distance going to be? Now that I know, according to this slope, that that is the correct point. Now, mind you, if I wasn't able to do that, I'd have to go through and use an equation of a line, come up with all that stuff. So one way it went 2, call that A. B, hypotenuse C again. So A was 2. B squared, 1. It's equal to C squared. What's 2 squared? Well, that's 4. 1 squared is 1. So that's going to be C squared. So 5 is equal to C squared. Square root of 5 is equal to C. So how far is it? Square root of 5 units. Nothing more that you can do with that. But leave it like that. Don't try and put it as a decimal number unless you are told. Okay. So, I'll give you a few moments to get those taken. All right. We've seen these before, especially the last one. We've gone through this idea that a perpendicular segment from a point to a line is the shortest distance. Now, would it make sense for it to be from a point to a plane? Think about it. If you're holding a ball in your hand and you let go, it goes straight down, doesn't it? Gravity is pulling straight down, so it comes down and it hits the floor at a what angle? Right angle. That's provided that the floor is straight, right? So if two lines are parallel, then all points on one line are equidistant from the other line. So that idea we've talked about with being parallel. So let's say I want to go through and I want to prove that this is going to be the case here. I've got line M is parallel to N. So if I look at this, well, if I got parallel lines there, and I see that that is the same as that, so we've got angle ABC is supposed to be congruent to angle DCB. Why? What would be the reason for those two to be congruent? Parallel lines, transversal, opposite sides of the line. Corresponding angles means they're in the same place. Not quite. Yes, sir. Alternate interior angles. Both angles are on the inside of the parallel line. They're on opposite sides. So by AIA, we know that these are going to be congruent. So I see something else here. Can I say that angle BAC is congruent to angle CDB? Are they congruent? Why? You're nodding your head, Miss Anderson. Why are they congruent? Well, what do you see? Okay, they're triangles, yes. But what specifically about that, the angles that they are there? They're right angles. So what do we know about all right angles then, Jacob? They're all 90 degrees. They're all the same, right? So we know that right angles are congruent. We know that. So now I look at it and I say, hey, what about this? Why? That's the reflexive, yep. So if I bring this down to, say, triangle, let's see if I get this right here. Triangle ABC should be congruent to triangle DCB. Why? HO. That's hypotenuse angle. Yeah, I could do that. Well, do I got another one? Since I really didn't think about these in terms of a right angle, I would have only needed, I got three things in there. What are the triangle congruence terms besides the right ones? I don't always like using those, but that does work. Well, it does. I have two angles and I do have a side, but what's the order? Angle. Yes, it's angle, angle, side. Okay. So if those triangles are congruent, then I know that, whoops, sorry. Then I know that segment AC is going to be congruent to segment DB. Why? Well, corresponding parts of congruent triangles are congruent. So let's try this one. Pizza delivery, or a pizza restaurant only delivers to customers who are less than 3 miles away. Okay, it says the restaurant is located at the origin. So we're going to put the restaurant sitting right about here. So that means that we've got it going up this way, we've got it going up this way, we've got it going up that way, and we got to go that way, right? Now, if I want to go and do 3 miles away, is that kind of like a circle? Would a circle identify 3 miles away, or should I do a square or do something else? Oh, I could do whatever I want. This is true, but my problem is each one of these is a mile. 1, 2, 3 goes out to here. 1, 2, 1, 2, 3 goes out to there. 1, 2, 3 goes there. 1, 2, 3 goes there. It would have to be a circle. Okay, so we're going to grab a circle here, and I'm going to make a circle that goes out that far. Okay, so here's my 3 mile radius. Goes out 3 miles in every direction. Now I'm going to graph that line, and it says plus 3, so that means the y-intercept is here, and a slope has negative 1 over 2, or negative 2 over 1, so down 2 over 1, down 2 over 1, down 2 over 1. So I now have my line going through here. But he's on 5th Street. 5th Street is more than 3 miles away, isn't it? Well, I don't know either, because I don't know what street the restaurant's on. So I can't necessarily say that, you know, hey, that's the way it's got to be. But because of what they described, and that they told me this, who lives at the closest point to the restaurant on 5th Street. Would this be the closest point to the restaurant on 5th Street? Because that's the closest it gets, right? So is he close enough for delivery? I'd say so. So what I'm going to do is I'm going to give you 3 minutes to do these 3 problems. So here we go. First point. Let's see, -3, 1, 2, 3, 1, 2, 3, 4, 5. So there we are. So we're at -3, comma, -5. So far, so good? So first line that we've got here is supposed to be at y is equal to 6. Well, y-axis is here. 1, 2, 3, 4, 5, 6. So then, how far is that line, Colton? Okay. So this is 5, that's 6, so that distance there has to be 11. So this will be 11 units. So let's see. I got an x now that is supposed to be at what? X is at 9, so x is at 9 is going to be sitting up over here. That is not what I wanted it to do. Oh, I don't like that when it does that. Let's try that again. That was real helpful. Occasionally this stuff actually does work. There we go. So I got the line sitting over there this time. How far away is this one going to be? Well, you should have it down on your paper, don't you? Anna? Oh, okay. Okay. How far is the point away from this line? 14. You sure? So if it's 9 units one way, 3 units the other way, it'd be a total of how far then? 12. Okay. So Parker, what did you get for C? Why haven't you done that? Okay. Do you see where the lines have to go and now how far you got to count? Because really all you got to do here is count up. Let's see, -3, 5. Evidently my grid did not end up where it's supposed to be. What's happened to my grid? I have no idea what happened to my quote. My grid is all shot. You ever have one of those days when that happens? Every day, I know. Okay, so back to here. Put everything back. Delete that. Grab me a new grid. And let's see, this one's supposed to be up here. That we know it's at 9. Oh, that's what happened to it. It all unhooked itself. So that's at 9, and this one was supposed to be at what, 6? 1, 2, 3, 4, 5, 6. So there we go. Now we got all that situated again. And the thing is, it's important for that to be that way, isn't it? So let's try this now. We have to go through and it's all messed. I'm having a bad day, aren't I? Let's try that again. One, 2, 3, 4, 5. You don't have to start talking just because I'm having technical difficulties. So, the distance here, Parker, have you been able to figure it out since I've been having technical difficulties? No, right? So, y-intercept is at 0. Slope is 2 over 1, so that means it's going to go up 2 over 1. Up 2 over 1. So now that I know where that's going to be going, I can go and put in my line. Now, one of the things that you are going to notice that when you try and draw in lines, you draw 3 points in there, but it doesn't look quite right, does it? Even if you have got a ruler, always, back it up. Down 1, down 1, down. So now I've got even a better idea. We want to be as accurate as we possibly can with this. So go through, draw in my line. Now, as I am looking at this line here, does it get close to it? Does it touch it? Or doesn't it? No, it doesn't. So we've got a problem now. We got to figure out what the distance is to that point, right? Or is that the wrong point to be looking at? Yeah, because you got to read the instructions. Parker, did you plot 6-2? Okay, 1, 2, 3. Put this down there then. 1, 2, 3, 4, 5, 6. 1, 2, sitting up over here. Okay. This looks like it's easier to deal with, doesn't it? So, first offhand, what is the slope of the line? 2, what's the slope for the perpendicular line? -1 over 2, opposite reciprocal. So that means I go down 1 over 2, down 1, 1, 2, down 1, 1, 2. Hey, it hit it. So how far down does it go? And how far over does it go? Oops, I was right at the beginning. So it goes down 2 over 4. So that means it's 2 squared plus 4 squared is equal to c squared. 4 plus 16 is equal to c squared. 20, I said 20. Okay, square root of 20 is equal to c, which is 4, correction, 2 square root 5. So there we go. So there you go, Parker. Now you've seen how that's done. So let's try this. I'm going to give you a couple of minutes here, and I want you to do this one. So Keely, did you find by chance the closest point? Not really. So I assume that you plotted out the 0.54, 1, 2, 3, 4, 5, 1, 2, 3, 4. Did you do that? Okay. Now you got to graph that line. Easiest way to do that is slope-intercept form. So going through here at -1. Okay, so we got our y-intercept, and our slope is simply 3 over 1. So up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay, so it looks like I got enough points there to hit it, right? It's going to be somewhere in that, right? So now, we know it's got to be a perpendicular line. So the perpendicular line would be -1/3. So if I go and do the slope here, you know, down 1 over 3, 1, 2, 3, down 1, okay, back it up, 1, 2, 3, up 1, 1, 2, 3, up 1. So it hits that point right there. And so the closest point is going to be whatever that is, which is 1, 2, comma, 1, 2, 3, 4, 5. And so there we go. That's the closest point. All right, I'm going to let you guys get to work. Due tomorrow into 5.